we had Andrei, now we are going to have Andres. And fun fact about Andres is that he was a coordinator of a local TEDx, so hopefully he will use some of the experience from there. He's a senior iOS developer at Revolut, and he came to us from London. He also developed software for hospitality, transportation, airline, and fintech industries. And his talk is going to be about key challenges and solutions in building iOS app in rapidly growing environment, both in the context of codebase and team. So please give a warm welcome to Andres Cecilia Luque.
Okay, now I have it. Super. Okay, yeah, so I'm Andres, I'm working at Revolut, and I'm the third Spanish speaker today, so I hope you love the accent, because mine is the strongest one. So yeah, I want to start with a question. How many of you actually work in a team that is 30 developers or more? Raise hands. Come on, wake up. Wake up. I see 30 iOS or more. iOS developers, only iOS developers. I saw like 10 people, maybe, something like that. Fair enough. Okay, so I'm going to be talking about how you can scale a team. How did we do it within Revolut? So the idea of the talk is coming from my experience in Revolut. We found a lot of challenges while scaling the team. And then I also found out, talking with other companies, that the problems that you find when scaling the team are the same in all the companies, and the solutions you end up coming to are also very similar. So yeah, let's go for it. A bit of agenda. I will talk about Revolut a bit to put you in context, and then we'll talk about 3 of the main problems I find, which is increase of local build times, increase of CI build times, and when the tooling gets out of control. I'll have a mention about module layout, and finally we'll go some conclusions. Yeah, so let's go a bit of Revolut. So for who doesn't know who is Revolut, we're a bank. At the beginning, we started in 2015, mainly focused on people traveling, because yeah, the app was basically having great exchange rates and was super easy to get cash abroad. Moving on to today, which we are a super app that is offering a range of products from investment, insurances, personal financing, crypto. We have 18 million users, 36 countries, 90 iOS developers. We want to grow the team to 100, so we are hiring. We have a booth outside. We have some swag, and will not make you overwork for the swag. We give it away very easily, so pass by, check it out. Yeah, and let's jump into it. So basically, I'll give you a bit of context of our code base. What you see here is some statistics about the repository. On the top is the amount of developers on the team from 2014 until now. The amount of lines of code and the amount of commits. Basically, what you can see here is during 2019 and 2020, the company went through incredible growth, and you can see it reflected on the engineering. This is how incredible growth in a company looks for engineering. The team grew from 20 developers to 70 developers in less than a year. As you can imagine, the infrastructure couldn't cope with these new developers. So we faced some challenges, and that's basically what I'm going to be talking about. So usually the first of the challenge of the problems you find when scaling is that your local build times start getting unmanageable. What you see here is the usual evolution of a project. So usually you maybe start on the top left, where you have a very simple app, some tests, and you have one Xcode project. The Xcode project is the orange square. Eventually, you add a couple of developers to the team, you keep developing, there is more code, and then things start getting slow. Xcode starts not indexing so well, and then somebody comes with the idea, okay, let's modularize a bit, let's start making targets inside the same Xcode project. That's what you see on the middle. You have some feature modules, you have some core modules, but it's still on the same Xcode project. And this is all good for a bit, but then the problem keeps appearing. Even if you modularize the targets, Xcode is slow. So usually teams are forced to do the third level of this, which is what you see on the right, where you chop even more, this time chopping also in Xcode projects. So you have different Xcode projects for the different modules. In this case, for example, if you are building feature A, you don't have to be building feature B or the core modules. And some of you may say, okay, cool, we modularize, we have all these Xcode projects, but if I introduce a screen on one of the feature modules, how do I check this screen? How do I look into it? Because the application is not anymore in my Xcode project, it's in another Xcode project. So one of the key points of this idea is that you have to introduce sample apps. Sample apps is very simple, small applications, basically a table view that are used to run the code in your module. So what you can see is that usually what you will find is you have your feature module, you have your test, and then you have the sample app. And I'll give you an example here. So what you see on the left is the full Revolut application running, which the trading with the trading product, the stocks. But you can see also some other products. You can see accounts, cars, crypto, vaults. And what you can see on the right is the trading sample app. So for example, the trading team has this sample app, which basically can run all the trading product, but only the trading product. So when they are developing, they are not building the whole app, which is at the point we are in Revolut is impossible to work with. They just build and index the trading code base. And what you see on the sample app is they can, for example, launch the full trading product against the development backend, which is the main cell you see there. But then you can also open the screens individually, mocked screens, which is what you see below, some screens. Basically, this is up to your team. You can have flows, mock flows, live flows. Yeah. So now that you're settling into modularizing, the next question usually from people is like, okay, how do we do it? Are we going to go for multiple repositories or are we going to go for one repository? Usually, the first try is to go for multiple repositories, and this is basically because it's very extended. It's very well known in the community to have multiple repositories for the different libraries. If you look into the documentation from CocoaPods, from Swift Package Manager, everybody is explaining very well how you create a new repository, put your package there, and happy life. And it's also clear ownership, right? You have different repositories. It's very clear who is owning this repository, is what you see in open source. But this is not really a great solution for a company that is trying to move fast because it requires versioning. Of course, when you have multiple repositories, you have to version your libraries and use them. It has difficult integration because now you have all this code spread around different repositories, but it's still for building an app, you have to bring it all together. It's difficult to implement tooling. So if you have some scripting, you have some Swiftling rules, for example, now you have to be copy-pasting these rules all over the place or having some fancy way of doing it. It's difficult CI support because now you have to set up multiple repositories on your CI. And yeah, that's not fun. Usually it's manual work. And basically, if you think about it, in terms of having 50, 100, 200, 300 modules is completely unsustainable. We cannot have 300 repositories and version them and integrate them. So in the end, what most of the teams end up finding out is that the only way to go is mono repository. It's integration. There is still integration needed, but there is no versioning. So that's a big problem that we don't have to solve. Easy CI setup is one repository you set up, and that's it. If you implement some tooling, you can run it on the full code base. You don't have to go into other repositories. It's ideal for build systems that are specific for large-scale code bases. We'll see it a bit later. Most of them work with mono-repository idea. But the only problem with this idea is that it's not very well known, and maybe it requires a bit of ownership definition because now everything is in one repository, so most of the teams have to end up developing some ownership infrastructure. Yeah, but this is, from what I know, the companies I've talked to, everybody's using mono repositories when you are building large-scale applications. So go mono repository. So we have modules, we have mono repository, And now, how do you integrate all these modules? Because I told you you have multiple Xcode projects, but how is everything coming together, right? How do you put these modules together into the app? I'm going to show you 3 ways of doing it. First way, Swift Package Manager. A bit of detail. So what you see on the left is the layout on disk. I'm showing you this example where we have a feature module depending on a core module. So what you see on the left is the Swift package specification. What you see on the middle is classic Swift package manager, where the 2 highlighted things are first, the origin of your dependency. This is the specification of the feature module, so it's depending on core module. So first you have to write somewhere where is the core module. And second, you have to write the dependency relation, which is top and bottom. And then on the right, what you see is what happens when you open the feature module project. In this case, Xcode is creating the dependency, and what you see there is both the packages. Nothing crazy. The problem with this approach is mainly 2. First, you don't have control of the build phases. You cannot add build phases here, and that's in many times critical for the teams because you have to run some Swiftling, you have to run some tracking. There is always you have to do when triggering a build. And the second problem here is that Swift Package Manager doesn't support applications. And as we've been talking before, sample applications is a key part, a key idea of modularization. So yeah, I don't think it's ready yet. Let's see if 1 more year. Let's go for second solution. You can use CocoaPods. I've heard about this approach in multiple companies, so I'll explain a bit. It's basically the same idea where you have specifications with the dependency specified. What you see on the top is a pod spec, which declares the dependency relation, and which on the bottom is the pod file, which declares the origin of this dependency. If you run CocoaPods in this feature module, what you get is what you see on the middle, a pods folder with different projects inside. And these projects are fully working projects. You can open them individually, and you can develop on them. So that's a way of getting Xcode projects and integrating. And what you see on the right is how it looks when you open the feature module Xcode project, where CocoaPods Xcode has created the dependency of the feature module and the core module. This is the approach we are following at Revolut. It's not the best approach because it's not really flexible. Pod specs have limited configuration. But we are using it because of historical reasons. We are coming from a full CocoaPod setup, so the natural way for us was to use this way of keep integrating with CocoaPods and generating the projects in this way. Of course, we have some magic automation to make this straightforward. Yeah, and let's go for the third option, Xcode. Similar idea, what you see on the left, the specification, which you see on the middle, the Xcode specification with the origin of the dependency and the relation, and on the right, how it looks when you open the project. And this is, in my opinion, the best way to go, because Xcode has so many possibilities in terms of configuration, build settings. It's super easy to do. So yeah, this is where we want to be in Revolut eventually in terms of integration of the modules. And this is basically how you solve local build problems, by splitting your code base. And then some time pass, and you keep adding more developers, 10 developers, the code keeps growing, and the second problem you find it's increasing build times, right? Because even though you are modularizing on development, the CI keeps running the test for everything, keeps building everything, and at some point you're like in 30 minutes, builds, PRs are super slow, it's getting out of hand, right? So let's see how we solve this. So the first thing to think about is how powerful are the machines I'm running the jobs on, right? I would say there are 3 main options at the moment for machines on the cloud. You have third-party hosted virtual machines. You have third-party hosted Verbon machines. A Verbon machine is one where you run the code directly. No virtualization, nothing, just a full Mac. And then you can have the self-hosted Verbon machines. Virtual machines, when running, when building code of large scale, is no go. It's too slow. So first step is if you're using virtual machines on your CI, move on. That's it. There's no other way. But they are very popular because they are for free, and many open source projects use it. GitHub, Azure Pipelines. They work for open source smaller projects. And then of the 2 options the 2 Verbon options are of course the fastest. If you go for third-party hosted, you will get also the software that these companies introduce. Basically, when you run a job, they serve you an agent that has a known state. no weird caches, no weird tools installed on the machine. You can rely that the machine is in a state that you know. Versus if you self-host it, it's very difficult you have that, right? Because this software is not trivial to implement. So in the end, when you're self-hosting, you have to be more careful because your machines will probably have cache from the previous job, or will have installed something with Prune from the previous job that can mess up with your build. And the other difference is that if you are going for Amazon, it's extremely expensive. It's so expensive that many companies go for self-hosting, even though it's going to be more work for the developers. Yes, and then a couple of other negative points for self-hosted. Setup complexity and maintenance. Of course, you have to update the operating systems, you have to update the Xcode, you have to keep these machines up and running. So that takes some time. The Revolut way, we have self-hosted machines. We have 12 M1 machines and 8 Intel. These machines are running 60 pull requests a day, and they are supporting the full team of 90 developers. What you see on the right is our pool of machines. The way we set up these machines is pretty rudimental. It's just a bash script, and this bash script is basically cleaning up cache, installing whatever tools we need on the devices. The idea is that you run this script, and the machine is in a known state after that. So we will have some machines misbehaving. We just run the script. That's it. Problem solved. That's the idea. It will also take care of updating Xcode, installing Xcode, all this kind of stuff. And the most problematic still is operating system updates because it's difficult to make them remotely. So at the moment, we don't have so many machines. We have IT updating the operating system every year. So not a big deal for now, but consider if you're running a farm of like 100 machines, then it's going to be challenging. And important mention, it's to not install tools globally, both for developer machines and for CI. How can you do that? If you're using Ruby, use bundler and install locally in the repository. So you can do that configuring the bundle path, which is what you see on the bottom right. If you're running other tools, try to get binaries from them and try to store these binaries locally to the repository and run them. So either you commit them in a sub-module or you download them from the cloud and run them, but don't install them globally neither on the developer machines or the CI machines, because I don't want to find some weird tool in my machine suddenly when I'm running Revolut project. I think that's for CI. So when you've done that and you're sure you cannot get any more performance from your machines, the second way usually people think is like, okay, I'm going to try to pre-build some of the code. Why am I building all this code all the time if it's not changing? And the first culprit is third-party dependencies. Everybody's like, okay, now we're going to be pre-building third-party dependencies, and we'll cut the build time there. And then you start thinking how to do it, and you figure out, okay, I can script some stuff, so I build my frameworks, but then there is Carthage, right? Carthage is like the main tool for building binaries. But you figure out, okay, it's not so easy because Carthage support is very limited. Most of your dependencies, for sure, not even half of your dependencies in the project will have Carthage support. So how do you do it? I'll show you a way. So you can combine CocoaPods and Carthage to get binaries from your pods. The idea is rather simple. You create a standard CocoaPods project. You add all your dependencies to the pod file. And the trick is here, you create a share scheme with all your pods. The share scheme creation is what you see on the right. It's basically iterating over all the targets on the pods project. And basically it's creating a scheme with all these targets and sharing this scheme. It has to be shared because Carthage only will build share schemes. And basically just run Carthage on that. The command you need is the one on the screen where the main part is no skip current, which basically tells Carthage, hey, create binaries for the project that is currently in the current directory. And then you get your binaries. And then for hosting them, you can go, I think, a couple of ways. Some modules, and you commit them on a some module if you have a lot of space on your hosting. That solves the problem for versioning and stuff like that. And the other option is you put them on Google Cloud, and then you have some versioning system that you can download these dependencies. There is no point in using ROM, in my opinion, because you can zip all these dependencies and download them. They don't change so much. So we tried using ROM, and it was a bit, it doesn't work so well. So, and then for integration, your tool of choice, basically if you're integrating with CocoaPods, a pod spec, if you're integrating with Swift Package Manager, package.swift spec, wrapping the binary, and if you're integrating with Xcode, similar. Okay, your third parties are pre-built, your CI is the most powerful possible, and still you have slow CI build times. And then you start thinking, like, what do we do every day? We just make a pull request, we change a couple of lines, 100 lines, 60 lines on a module, but still CI has to build everything. Why? There's no point. CI has to only build the module I change. CI has to only test the module I change, right? So basically that's what you see on the screen. What you see on the screen is a dependency tree where, for example, there is a change on network, and the only thing that CI has to build and test is network, feature A, and application. And the rest of the stuff, no, it should be cache, right? So the first solution is you have to leverage local cache. You have to have a tool that is able to cache the stuff that you are not building. The second is, how cool would it be is you don't only leverage local cache, but then you have some way of getting this cache to the cloud and distribute it among both the CIs and the developer machines. That's called remote cache. So the other option is you leverage remote cache. And there is a bit of a detail here. Builds have to be deterministic, and this means that a build that is done in one machine has to be the same binary that is done in another machine. This is a bit complex because different machines have different paths, different machine names, all this kind of stuff. So it's challenging, it's doable. And then the third step is what I've said, you have to cache test results. So there is no point on testing feature B in the example you see on the screen. And you may think, okay, but if I'm caching test results, maybe I have a flaky test, and then I cache it, and then it's green all the time. It's still going to be flaky, but because I'm not running it, it's going to keep being green, right? The way to solve that is you have a job that runs overnight, and this job overnight will actually run all your tests and will take 2 hours or whatever it takes. But the idea is that during pull requests, you have very quick builds. Overnight, you may take 2 hours to run your test, and then you notify the developers, hey, this test is flaky, check it out, fix it. Yeah, so that's how you solve the long CI build times. I gave you the concept. I don't want to go into the detail of the implementation, but basically the way you can accomplish this caching, remote caching, and caching of tests is by using Bazel. Bazel is an alternative build system. And what you see on the screen is some statistics of our code base. So back in June 2020, we didn't have Bazel. We were having 22 average minutes of build time in CI and 2 million lines of code. Currently, we are having 4.15 million lines of code, and we are having 11 minutes build times, thanks to all basic Bazel, and then also one more detail I'm going to mention now. So what you see on the screen is the graph of only our Bazel builds. What you're seeing is, yeah, it starts on 10 minutes, and it grows a bit, of course, with the code base. The circle on the left is the moment we enable remote cache. It's maybe small, it maybe looks small, but it's a reduction from 15 to 10. It's a 30% reduction. And the circle you see on the right is the moment we switch CI to M1. So just to say that it's important to have powerful machines. I mean, you may be like thinking and coming with all these great engineering solutions for 3 months, and then suddenly it's just about changing your machines. Yeah, so that's basically our take on that. And then you may be thinking, okay, but all this stuff you're talking about requires a lot of scripting, right? You have to create projects, and you have to create them for all these modules, and maybe you're also running other kind of different tools on the modules. Basically, the idea now is that you have many modules that all of them are the same, and you have to run the same tools on all of them. And you start creating Python, Ruby scripts, Bash scripts, in a Swift, in a scripts folder or something like that, right? It starts getting very nasty. So it's getting out of control. So let's see. What you need, really what you need first is you have to be able to run commands from any location on your repository. You cannot be installing things globally, as we mentioned, and you cannot have people writing --dash Swiftlin. So you have to have a way where you can trigger commands from anywhere in the repository. One way to solve that is by creating one global tool. So you actually install something globally, which is what you see on the right. This is a brew formula that installs this 6 lines script on the machines. And that triggers, this way you can, for example, we call it repo, so you can trigger this repo from anywhere in the repository. You need a stable and documented API, so you also don't want the developers to be running pod install, xcode, because that's implementation details. The way you create these projects, as an example, creation of the projects, doesn't matter. So let's switch that for something that is like create project. Your API has to be stable, so you have something like, you write create project, the project is created, that's it. You document this, people can read what it's doing, and then you are hiding the internal implementation, and one day you want to switch to xcode, nobody's going to notice. You want to switch to CocoaPods, nobody's going to notice. It's stable, it's documented. And what you see on the bottom right is exactly that. We created this Ruby, at the beginning, this is the first solution we worked for, is a Ruby wrapper that creates this stable API. We call it proj. So for example, our developers, when they have to open a project, they just go to a module, they run repo proj, get an Xcode project. That's it. And still, at this point, your scripts may be completely nasty, like multiple languages, located in some weird places in your repository, but you're already creating this AP layer between the users of your scripts, the developers, the team, and the implementation. So now you're free to change anything, but if you don't alter the API, that's going to be fine. Yeah, so now you are like, okay, what do I do with all these nasty scripts? Wouldn't it be nice if I could have some organization for them, and maybe some testing, and maybe some type safety, and why not write them in Swift? So yeah, you can write your scripts in Swift. It's really no trick. You just create a Swift package and go for it. Benefits: one unique language and location for all the scripts. The scripts are not anymore in some weird folder. They're going to be in a project that everybody knows about. You open the project, you see the scripts. Known language and developed platform. I mean, you're spending so much money hiring all these developers, professionals in Swift, and then you have all the scripting in Python. What's the point? People is not experts on Python, so they cannot really take advantage of the Python tooling. But you put it in Swift, and they will know how to make a test module, how to run the test. Yeah, you get type safety, really important. You get the stability. You can use also the same conventions you use on your application code into your script. So you use injection, you use mocking, everything. And then something surprising is that when you are at this point where you can actually rely on your infrastructure, you can start building more complex tooling that you would not even think about when you have just some 60-line bash script and you're like, okay, if this keeps growing more, it's impossible to maintain. But now I'm confident on the tooling, so I can write whatever, 40 lines of Swift classes that is doing some complex actions, and it works. So yeah, that's basically how you get your tooling under control. Quick mention about module layout. It's important to keep an horizontal dependency tree. So what you see on the screen on the left is a vertical dependency tree, on the right an horizontal dependency tree. What I'm talking about is that you have to go for the right, because on the left what you see is that if you make a change on some of the feature modules on the vertical chain, then you're triggering a rebuild of all the upstream dependencies. This means that if your tree is vertical, you're going to have longer builds, even if you're using Bazel, even if you're caching your modules, even if you're doing all the things that I explained before, your build times are going to be long. But if you go for an horizontal dependency tree, what you see is you have a pull request, you change something on your module, and only your module is changing and getting built and getting tested. And you can have thousands of modules horizontally, because that's going to be the same experience for every pull request. You see? So I think that's it here. And basically, let's run some conclusions. So for reducing local build times, modularize. For reducing CI build times, use M1, bare-bone machines, and use Bazel. For supporting infrastructure, use Swift. And if you want to be able to grow and grow a lot, you have to have horizontal dependency tree and use local caching for building and testing. I think that's it. Questions?
Okay.
Thank you for a great presentation and presenting everyone with Swift scripts and way to distribute them using Brew. That's very cool. I saw you used Bazel, and I wanted to ask you about integration of Bazel with using at the same time Xcode Gen. And I saw on your GitHub that you also checked Bazel and Twist combination. How would you compare these two?
They are not comparable. So Xcode and Twist, they are for project generation. Bazel is for building.
Yeah, but integrating Bazel using Xcode Gen,
yes,
and also using Twist, those two approaches.
So you mean Bazel plus Xcode Gen and Bazel plus Twist?
Yes.
Twist, I never use it. My understanding is basically the same as Xcode Gen. But yeah, basically with Bazel, the thing is like you have to create also specifications for the modules. I didn't want to go into the detail of the implementation, but basically Bazel, you have to go and create also one extra specification in your module that will have the dependencies, and Bazel will be able to build your stuff. And then you have a second problem with Bazel is that you need an Xcode project that you can build stuff on CI from command line. It's great, and you can build it fast, but then you can also you have to also open a project and be able to work on this code. So that's where Xcode Gen or Twist come into the equation, where you have a parallel specification for Xcode Gen, and then you can open the project. So basically, you are maintaining two build systems at the same time. It doesn't mean you have to maintain them. It means that you have to make some automation, so your specifications are auto-generated, for example. So either you maintain Bazel and then you auto-generate the Xcode Gen specifications, or you maintain your own specifications for the modules, and then you generate both Bazel and Xcode Gen or CocoaPods or whatever you want from those specifications with some tooling. About this tooling, there are some stuff in GitHub, but the problem is that all the companies that are using Bazel, which is they are allowed this, it's all the big companies are using Bazel. The problem is that project generation is very specific to every company. So even though there are some tools out there, there are not so many of them that are really used by these companies. It's people that have been developed them and they are maintaining as part of the community. But in the end, most of the companies have their own internal project generator. So what I explained you in Revolut, because we're coming from a CocoaPod setup, the natural for us was to use what I showed you before with CocoaPods to generate the projects.
Okay, and I also wanted to ask about remote cache. Do you have some your own implementation, some your own tooling, or maybe use something like X remote cache by Spotify?
No, we use Bazel. Bazel has local cache, remote cache, test caching, it has it all. And actually implementing remote cache was a breeze. The moment you have Bazel working, which is extremely difficult to get set up, the learning curve is difficult at the beginning. Then you just enable remote cache. And the only thing you have to have in mind is you need deterministic builds, which can be tricky because when I build something on my machine and then I build something on my friend's machine and then I see that the resulting binaries are different, well, you have to debug it, right? It's not easy. How do you understand why this binary is different? Is some date that the Xcode build when building introduced, there is some path, something like that. So it's a bit of investigation. But yeah, when you get there, then it works.
I saw one hand somewhere here. Okay.
Thanks. On your slide about the remote machines, you had a list of remote machines, which I assume you could use to access their using SSH or something. Is this something? Is this like a tool you build for yourself, or what is this? Because I like it.
The image on the right?
Yes.
That's TeamCity. So the setup we have is TeamCity. We have our own machines hosted. These machines have some Java agents running on them. Basically, they are N1 machines we have in the office. And then TeamCity takes care of distributing the jobs and everything, so we don't have to build anything.
Okay, thanks.
Great presentation, thanks. I agree with many of the points. I have one question though. with the monorepo, how do you manage ownership and permissions? Do you use any tooling, or do you just do it at code review level? Or
Yeah, so I think that's really there is one good way to do it, which is basically introduce a tool that can look at the diff of a pull request and add the developers that mainly touch this code, right? In Rebel, we are not yet the ownership system we have ownership per module, where we have teams that own the different modules, and when there are changes on these modules, the people that is owning these modules, it gets added automatically to the pull request. But yeah, I personally eventually want to get to a point where it's kind of a mix. Okay, somebody's owning the module, but at the same time, there is people that is been mainly working on that code that maybe is not from the team. So this is really more of a policy. How do you want to assign ownership? But basically, the idea is that whatever tool you use, you have to look at the diff of a pull request, figure out the paths that are changing, and saying, okay, these files that have changed, who are the owners? And then you get a list of owners, and then you say, from this list of owners, I'm going to choose 3, 4, 5. How do you choose them? Well, up to you.
yeah, so basically, for now, your opinion is like the code review system is enough for your scale, but maybe it needs some tweaks. But
yeah, our current ownership,
would you say you're satisfied with it? Oh,
it works.
That's the question.
It works. The problem is the problem it doesn't account at the moment. Our system doesn't account for who wrote the code. It just accounts for ownership of the model, which is fine. It works. It works well. I just would like to have a bit more flexibility there on saying, okay, we are adding the people from the team that is owning the module, and then also this other person that maybe moved teams last week still should be looking at this code.
Okay, thank you.
Okay, one more.
Hey, thanks for a great talk. Question about this shadow dependency graph. Do you guys have any way of versioning those dependencies? Because it's not very realistic that this dependency graph will be just 2 layers deep, right? Some modules will rely on networking or design system, and there's going to be plenty of modules referencing them, right?
Yeah.
So I see 2 ways. We either don't version it at all, right? And then if you do a change to an API of a module, then you need to bump like hundreds of modules, right? Or you have some sort of versioning, which I don't imagine how you do it in monorepo.
You cannot have versioning. If you are sustaining, imagine having versioning of 300 modules. How are you pumping versions? Like, everybody has been there, right? You have a dependency that you are maintaining. You make changes on the dependency. You release a tag. You go to the other repository. You update the tag. Then your integration test failed. You go back to the previous repository. And that's only one. It's impossible to do versioning on 300 modules. So, of course, you don't have versioning. The problem is, if you are changing a public API that is used all over the project, then you are having to make updates all over the project, which it makes sense. There is no other way around it. Either you do it now, or if you are using versioning, which is, I think, it's impossible, then you do it a bit later. But you have to think about it. These APIs that are used all over the place, because you know the cost it takes to change them, usually they are not going to be changing. If you're going to be changing them, probably you don't have a plan for it, a long-term plan, and you're going to have some ambitions. It's not just going to change the name of a function. Probably it's going to be, okay, we are going to be refactoring the full network layer, so let's commit into it. And then in that case, what you can do is incremental update, where you keep your old network layer, introduce the new one, and then with some automation, you notify the different owners of the modules, hey, update your networking layer, for example. So the way I would do that is I will have a bot written in Swift that goes every 3 days and looks at the modules, finds out who is using the old network layer and pings them and say, please update to the new one. And I don't know, give it 6 months and it will be done.
Okay, so you're basically saying every time I change the major version of the module, I clone the module and then I keep both for a while.
There's no versioning. Everything is in one repository.
Yeah.
So what I'm saying is that it depends on the amount of changes. Usually, what you're saying, you have a module that is for designs, and then you update an API. For example, you update the API of a button that everybody's using. Well, you have to actually update every module. There's no other way around it.
I wish that was it was that simple. Like if you have multiple apps built from like one monorepo, we're not on monorepo. This is actually what's holding us back from migrating to
Exactly.
monorepo.
It's because it's impossible to grow with multi-repo.
Yeah, the problem is we're building 2 apps, so they're slightly different.
We have 3 apps.
Okay.
Yeah, it doesn't matter. Like it's just about building modules. An app is a module also. It's a module with a bunch of build settings on the top and a wrapper and a runner. But yeah.
Okay. Really interesting. Thanks.
No problem.
Okay, I see one more, but it will be last one.
I'm breaking the record.
Hey, nice setup, and I would like to ask about the last part. I presume that you have App Store deployment also automated somehow. And do you use, for example, Fastlane for it when you send the app to the test flight and for the App Store? So,
Sadly, yes.
okay.
Yeah, we are coming. I mean, I show you how an app grows, right? We didn't do. You don't go from the first moment with this tooling because you don't have resources to maintain a platform team that is able to support infrastructure. So we're coming from a CocoaPod setup, like mostly every big project that was created 3-4 years ago. We are coming from a Fastlane setup, and then we have limited capacity. So at the moment, we are just releasing with Fastlane. Why? Because releases, I mean, nobody cares if they take 5 hours, 6 hours. Hours don't take 6 hours, it takes 1 hour. But yeah, if they were taking a whole day, I wouldn't really mind because I'm doing 1 build per day.
Mm-hmm.
So it's not a priority really at the moment for us to be changing that. I would love to change it. And because in the end, Fastlane, I mean, in my opinion, hides a lot of complexity, which is, I'm not sure is fully justified because in the end, you just have to, the idea is very simple. You just get a binary from an application and then you upload it. The only moment you may need Fastlane is to upload this binary because there's no good way from Apple. I think there is even an Apple way to do it.
The App Store Connect API.
Yeah, but Fastlane is creating a bit of an alternative build system where they are taking your project and they are putting special build settings on top and stuff like that, which, it's just complex to understand and to maintain.
Okay, thank you.
Thank you. I don't see anyone else waving to me. So thank you, Andres, for
Awesome.
your talk.
Thank you.
And